16. Elements in the periodic table. Materials, both natural and human-made, have unique properties. Some are made of one type of element, and some are made of combinations of elements. But what are elements made of, and how do they differ from each other? Each element is made of tiny particles called atoms. A pure sample of an element contains many atoms of the same type. For example, the millions of iron atoms that make up a piece of iron metal are of the same type and have the characteristics of iron. Iron atoms, however, are very different from atoms of other elements, such as gold or oxygen. The properties of each element depend on its atoms. Some elements are rarely found in a pure form. They tend to combine chemically or react with other elements. Scientists say that these elements are reactive. When elements react, they can form substances called compounds. Challenge: what are elements and how do they relate to compounds? Think of the world around you. Everything, from the air you breathe to the shoes you walk in, is made from elements or combinations of elements. Discovering elements. The idea that everything on Earth is made of a basic set of elements began with the ancient Greeks more than 2,000 years ago. Greek philosophers thought that fire, earth, air, and water combined to make everything in the world. Starting in the 1600s, early chemists realized that fire, earth, air, and water were not the basic building blocks of matter. They looked instead for substances that they could not break down into simpler substances. These substances are known today as the elements. Some of the earliest known elements were carbon, gold, silver, copper, sulfur, tin, lead, mercury, and iron. All of them elements that occur in nature. Until the 1700s, very few new elements were discovered. But in the mid-1700s through the 1800s, chemists learned how to create chemical reactions and physical ways to separate pure elements. With these new techniques, they found dozens more elements. By 1869, approximately 63 elements were known. These included hydrogen, nitrogen, oxygen, sodium, and aluminum. Stopping to think 1. In what way were the ancient Greek philosophers right about elements? In what ways were the ancient Greek philosophers wrong? Mendeleev and the periodic table of the elements. In 1869, the Russian scientist Dmitry Mendeleev developed the ideas that led to the modern periodic table. Other scientists had similar ideas, but Mendeleev made the most progress and published the first version of a table of the 63 elements known at the time. Mendeleev collected information on the properties of those 63 elements and grouped them in a way similar to what you did in Activity 15, Families of Elements. He used data that many other scientists had collected about the properties of each of the elements. When he arranged the elements according to their atomic masses and their physical and chemical properties, he noticed that there was a repeating, or periodic, pattern. For example, as the atomic mass increased from lithium to fluorine, the elements in between changed from metals to nonmetals and from solids to gases. He saw a similar pattern repeated from sodium to chlorine, and again from potassium to bromine. Mendeleev predicted that there were more elements that would fit into gaps in his chart, the first version of what came to be known as a periodic table. He even used the patterns in the table to predict the properties of new elements. Other scientists used Mendeleev's ideas and built on them to identify the elements he predicted. Later scientists found many more elements that follow the patterns he found. The modern version of the table is called the periodic table of the elements. Based on new data about the elements, scientists around the world have agreed on some changes to the arrangement of the table. The photo on the left is of Russian chemist Dmitry Ivanovich Mendeleev, who lived from 1834 to 1907. and a table, on the right, he developed based on the properties of elements. This reference was translated into English in 1891. Stopping to think, too. How did Mendeleev build on other scientists' work? How did other scientists build on Mendeleev's work? The modern periodic table. Today, there are more than 115 identified elements, and everything on Earth is made of these elements. Look at the current periodic table shown below. Each element is represented by a symbol that includes either one uppercase letter, such as capital C for carbon, or an uppercase and a lowercase letter, such as capital C lowercase a for calcium, or capital C lowercase u for copper. Each element shows an atomic number that corresponds to its order in the periodic table, and an atomic mass, as shown in the example of the element carbon to the left. From the periodic table, you can find out a lot about an element. For example, if you look at the element cesium, atomic number 55, on the periodic table shown on the next page, you will see that it is an alkali metal column. From this, you can assume that cesium is a highly reactive soft metal. On this periodic table, you can also tell if an element is a metal or nonmetal, because a dark stepped line divides the table into metals to the left of the stepped line and nonmetals to its right. Most of the elements that border the stepped line between metals and nonmetals are called metalloids. Metalloids have chemical and physical properties intermediate between those of metals and nonmetals. Aluminum is not classified as a metalloid because it has metallic properties. Metalloids are often called semiconductors because they conduct electricity better than nonmetals, but not as well as metals. Semiconductors, especially silicon, are essential components of electronic products. Stopping to think 3. Use the periodic table of the elements on the next page to decide whether each of the following is a metal or a nonmetal. Lithium, carbon, sulfur, calcium, titanium, and bromine. Most elements are solid at room temperature. The 11 elements that are gases tend to appear on the right and near the top of the periodic table. Their symbols are white. There are 2 elements that are liquid at room temperature, mercury and bromine. Their symbols are shaded in gray. You can also predict the chemical reactivity of an element based on its position in the periodic table. The reactivity of an element describes how likely it is to react or combine with other elements. An element that is very likely to react with other elements is described as highly reactive. This means that they will react with many other substances. The least reactive elements are the noble gases to the right. The most reactive metals are in the 2 columns to the far left of the periodic table. The most reactive nonmetals are in the halogen family in column 17. Stopping to think 4. Find magnesium on the periodic table. What is magnesium's chemical symbol? What family does magnesium belong to? Is magnesium a solid, a liquid, or a gas? Based on its family, would you expect magnesium to be very reactive, somewhat reactive, or not reactive at all? Forming compounds. Elements contain only one kind of atom. Other substances contain 2 or more types of atoms held together by chemical bonds. Bonds form when the atoms of one element are attracted to the atoms of one or more other elements. Substances with 2 or more types of atoms held together by bonds are called compounds. For example, the compound water forms when the elements hydrogen and oxygen react together. Sugars are chemical combinations of the elements carbon, hydrogen, and oxygen. Groups of differing atoms that are held together by chemical attraction are called molecules. The diagram below shows a water molecule made of 2 hydrogen atoms and 1 oxygen atom. There are more than 115 elements, and these elements can combine to form millions of compounds. To get an idea of how many, just look at a dictionary of the English language and think about how many words are formed from just 26 letters. Compounds have different properties than the elements that form them. For example, the compound we call water is a liquid formed from 2 gases, hydrogen and oxygen. Table sugar is an edible white solid formed from a black solid, carbon, and the gases hydrogen and oxygen. Stopping to think 5. What are 2 ways that compounds are different from the elements that form them? Chemical names and formulas. Scientists have created a system for naming compounds. These names often identify the elements that make up the compound. For example, the full chemical name for table salt is sodium chloride. This name tells you table salt contains sodium and chlorine. This is information about the compound that you would not have if you called it table salt. Notice that the ending of chlorine is changed to "ide" in the name of the compound. A chemical formula is a shorthand way to identify the kind and number of atoms that make up a compound. For example, the symbol for sodium is capital N, lowercase a, and the symbol for chlorine is capital C, lowercase l. So you can write the formula for the compound sodium chloride like this: capital N, lowercase a, capital C, lowercase l. This tells you that there is 1 chlorine atom for every sodium atom in sodium chloride. Not all chemical formulas are as simple as NaCl. For instance, water is made up of the elements hydrogen, capital H, and oxygen, capital O, and its chemical formula is H2O. That is because each water molecule is made up of 2 hydrogen atoms bonded to 1 oxygen atom. The number 2 below and to the right of H shows that there are 2 hydrogen atoms in a water molecule. When there is no number written below and to the right of the element symbol, then there is only 1 of that type of atom. Stopping to think 6. The chemical formula for baking soda is capital N, lowercase a, capital H, capital C, capital O, 3. What elements are in baking soda? How many of each kind of atom is represented by the formula for baking soda? Classifying matter: elements, compounds, and mixtures. Everything around you is an element, a compound, or a mixture of both. The oxygen in the air you breathe and the copper in pennies are examples of elements. The water you drink and the salt and sugars in the foods you eat are examples of compounds. So are the proteins, fats, and carbohydrates that make up the cells in your body. Everything that is not a pure element or compound is a mixture of elements, compounds, or both. Even air is a mixture of several elements and compounds, including the elements nitrogen and oxygen, and the compounds carbon dioxide and water. On the top, commonly referred to as salt, this naturally occurring compound is sodium chloride. On the bottom, ocean water is a mixture of compounds, including water, H2O, salt, NaCl, and others.